Hi folks, so for the last lesson of the week, and it'll be good to see you all again on Monday or Tuesday even, we're going to just do some practice of the trigonometry stuff. So this all comes from the mixed exercise at the end of the chapter, going through some of the things we've done all together. So copy down the question, pause the video, have a go, and then see whether or not you've done it the same way that I did. You may well have done it a different way, and that doesn't matter as long as it's a logical form that you can go for. Now, the first thing that I'd notice, if we want to get tan 2 theta, and we've got these signs, and we can change signs to coses where we need them, and we know that tan theta is sine theta over cos theta, so that means it stands to reason that tan of double the angle will be sine double the angle over cos double the angle. So it's going to be a good place to start by seeing if we can work towards that. Paper's really absorbent, so I'm going to go for some which isn't so blurry. So for that reason, we know that sine, if I keep root 3 sine 2 theta, if I take 2 sine squared theta from the other across to the other side, 1 take 2 sine squared theta, see that is one of our trig identities, isn't it? Cos 2 theta, one of its identities is 1 take 2 sine squared theta, so we can just drop that in. So then we've got root 3 sine 2 theta equals cos 2 theta. Now if I divide by cos 2 theta, but I also divide by root 3, I'll get sine 2 theta over cos 2 theta, and when I divide by that, that would have left 1, wouldn't it? And if I divide 1 by root 3, I get what I'm needing, so that is tan 2 theta there. So we've shown it, but most of the marks on this question are for solving the equation, so we're going to be using the fact that tan 2 theta is the same thing, so that's equal to 1 over root 3 of pi, so we can work out what 2 theta is going to be with tan negative 1 over root 3. Put that into the calculator, remembering to put it into radians first because I want it between 0 and pi. But because we're doing 2 theta, we're going to need to make a little sketch up to 2 pi, aren't we? So that's giving me 2 theta is pi over 6. And now if we do sketch from 0, there we go, that's 90 degrees as I always think of it, and then there's your 270, so pi is 180, isn't it? So pi is there, 2 pi is there, that's going to be pi over 2, so pi over 6 is about there. The next time that happens is going to be 1 pi more than that, so that's adding on 6 sixths, so that gets us to 7 sixths of pi, or 7 pi over 6. But we don't want 2 pi, we want 1, so we need to divide both sides by 2, and that means that, not pi, that theta is going to be pi over 12 and 7/12 of pi. So that's the first question we're going to do, and the next question I'd like you to have a little go at is question 10 straight away after it. So pause the video, give that a whack. Right, so this is going to be using the same idea that we had last time, isn't it? Which was, what was it? It was that cos 2 theta. Just remembering, if you look in your formula booklet, you get the cos A, cos B minus sine A, sine B. So that's going to become cos squared alpha minus sine squared alpha, and then we can use the identities that we know that we can call cos squared alpha 1 take sine squared alpha, and if we take sine squared alpha again, so that's replacing that with that, that gets us 1 take 2 sine squared alpha, just in case you are confused about that. So now all we need to do is put 1 take 2 sine squared alpha in instead of cos 2 alpha, and that's going to equal 5 sine alpha, and we just need to get it in this form. So if we add 2 sine squared theta to the other side, we've got plus 5 sine theta, so we've sort of come over this side, take 1 is equal to 0. And so if they say A, B and C are constants to be found, we've got A equals 2, B equals 5 and C equals negative 1. And then we're going to use that to solve the equation cos 2 theta equals 5 sine theta. So the value of theta that would do that. So we are, if we let x equal sine theta, we can say we've got 2x squared plus 5x take 1 is equal to 0. When it comes to having a crack at factorising that, it should be a plus 1 take 1, because 1 times negative 1 is going to give us that. But we're going to be timesing, we've got 2x, how are we going to get up to 5x? We're going to need more than, that's going to be a little bit complicated, isn't it? So we can always chuck it into the quadratic formula, or if we're feeling really lazy, we can just go to our good old favourite equation solver, polynomial, and what have we got? We've got 2 and 5 and negative 1, and that's giving us those two results there. So that's why it wasn't going to factorise. So if we put those in, we've got x equals negative 5 plus root 33 over 4, or negative 5 take root 33 over 4. But as that's sine theta, we can then say that theta is going to be sine negative 1 of, and sine negative 1 of negative 5 take root 33 over 4. So have a go at that. I'll put what I get to in a moment as well. And what you should end up with, you should get an error when you do this one. This one doesn't give us anything that we can use. This one does, those gives us 0.187. And when you draw your little sine wave between negative pi and pi, that's like minus 180 and 180, your 0.187 would give you a value about there. So when that happens again, it's going to be minus 0.87 back from pi, isn't it? Because it's a positive value. Okay. Right then, we're just going to do one more example before I give you a few to to have a go at, and this one's a modelling one, and it's one using Mr. Cooper's trick. So pause the video, give it a crack, and then see if you agree with this. So it's saying r cos, so we keep it as the 2 cos x take root 5 sine x. We keep it that way round. We draw our right angled triangle. They're wanting it in the form r cos x plus alpha, so we call that angle alpha. The 2 goes down to there, the root 5 goes to there, and the r is going to be the hypotenuse, so that'll be the square root of 5 plus 2 squared is 4. So the square root of 9, so r is going to equal 3. Tan alpha will be root 5 over 2. Alpha is tan to the negative 1 of root 5 over 2. And we just need to pop that into the calculator, so shift tan root 5 over 2 gives us 48.19, or 2 to so that means that we can say express it in the form y equals r is 3 cos x plus 48.2 to 3 significant figures, and that's part A done. Then we need to find the values of x between where x is values between 0 and 2 pi. So again, pause the video, give that one a go. And it did say when y equals negative 1, so I am looking at the equation 3 cos x plus 48.2 is equal to negative 1. So we're then going to have divide by 3 and then sine of inverse of cos. So cos minus 1 negative a third, and that gives us x plus 48.2 is equal to 1.91. So we need to draw the curve for that before we mess around with it. So our cosine curve is going to look like that, isn't it? Now where would that be? That would be pi, that would be 2 pi, so 1.91, or half of pi, is going to be about here. So we're going to need to take 1.91, 2 pi, take the 1.91, will give us 4.37. And this is where I realise, taking 48.2 away from that is all nonsense, because I've gone in degrees at the beginning and it's clearly in radians, but there's not a massive amount I have to do. It's quite good to see a mistake like this. At this point I just rake back through my calculator because it's got its memory. I've now turned it into radians once I spotted that little bit there, so I just go back to there and I press equals again and go back up to where it was, and it's turned it to 0.841, so it should be 0.84 there, 0.84 there, so that means that's plus 0.84, and then I'm going to be taking 0.84 from both of those to give me x being So that does give me 1.07, 3.53, and strictly speaking I should have had a 1 in there at that point because to 3 significant figures, but all good. Right, now the last thing I need to do is tell you which questions would be a nice ones to have a crack at. And I would like to suggest on that same exercise 7M, questions 11, 12, 16 and 26, and that should do it very nicely. Okay, see you soon. Goodbye folks.